Greetings and welcome to PinballHelp. Mike here. Today I'm going to do something a little bit different and hopefully interesting to you, I think. I'm going to talk a little bit about the art of coding for these old solid-state pinball machines. As you see in front of me, I've got a Bally Paragon. This is an original game from 1979. I've been doing a series on restoring it and all of that. Hey dogs, quiet. They always do that. They're very mellow until I start recording and then they start dancing around. I'm watching y'all. Okay, where was I? I've been doing a series on this game, restoring it, and I've got it back playing nicely. And this is basically the original game code. And it plays pretty nice and it's quite fun. Put this ball there. Have the glass off so it's a little loud. But do you ever wonder, like, what goes into one of these games? How does it actually know what to do? How is all of this stuff, the pop-uppers firing and scores happening and drop targets resetting and stuff like that, how does that whole thing actually work? Well, there's a program in here that controls the machine, and in these old games it's written in probably a macro language that's then compiled down to assembly or machine code, and it's burned into a ROM and it sits in a chip on the main board. More modern games are programmed with higher level languages running off of computers that load an operating system and then load the thing. This is a pretty raw early solid state game, so it's kind of it's just the electronics and the little bit of fringe code that runs it. And I want to talk about that because I've started to get into reprogramming these things, and it's pretty interesting just how much you have to kind of keep track of everything. So if you see this game, you see there's lights all over the board, there's targets and stuff. And keeping track of that, if you wanted to write your own rules, is no small feat. Everything has to be handled manually. This game has a base operating system, and then all of the game logic and the behavior and what happens, whether what lights go on, what points, what rules, all have to be manually coded. So let's talk a little bit about that. And I'm going to show you some early development that I've got with this particular game. So this is the original code, and it runs and it's scoring, and you've got all kinds of stuff. The ball goes in the hole, makes sound, and it bounces around and all that. So let me show you the custom code, which is right over here on the computer. So first thing I'm going to do is I'm going to go into the back box and I'm going to turn the machine off, and there's a switch in here. I guess I could show you what I've done so far. Let me see if I can go it around so you can see what is actually going on here. The camera. All right. So this is your typical Bally early solid state, but if you look up here you will find there's a homemade daughter board that is hooked onto the expansion plug on the MPU board, and there's a bunch of wires coming off of it. You see there's a switch there, there's an extra connector for a sound card, and then on the little daughter board up there is an Arduino Nano. So what we're doing is we're reprogramming kind of like a parasite sitting on top of that board. We're taking control of all of the I/O on the board, bypassing the main processing unit, and we have our own control code that's running on this game. Now, as such, let me go shut the door. Since we're completely bypassing all of the original game ROM, in order to turn this into a useful game, everything has to be completely rewritten. All the code that handles all of the hardware, the actual operating system. And so there's a small group of people out there headed by this guy in Maine named Dick Hamill, who has written a base operating system. It's called BSOS, B-S-O-S, Bally Stern OS. And it's basically a copy of the functionality of these early Stern and Bally solid state games, and then it's like a base where you can add and program your own stuff. So let's take a look at that. You've no doubt seen some examples of some of the versions of this game, this technology that's floating around. Stern Trident and Stern Meteor and a few other games have been already done out there. There's a handful of people that are also actively coding, myself included, and we're trying to mod some more games. So I've been learning the base operating system, and I've finally gotten to the point now where I'm actually able to code and start doing my own rule set and logic. And so I want to kind of show off what I've done. And in the process, I also would like to talk about how this whole thing works and the ins and outs of actually trying to do a rule set, because it will give you a lot of respect for these designers, at least the engineers and the software people, because there's a lot involved here and you have to be really careful. So if you see over here, I've got a little laptop set up. This is the Arduino IDE. It's basically just a little editor, and inside of this is the program code. And I'll just zoom in. And before you can even begin to control a pinball machine, you have to identify all the hardware ins and outs, all the coils, all the lights, all the switches, and they all have to be mapped. And every pinball machine is a little bit different. It's kind of interesting that you have to, and in this Paragon machine, we discovered the way some things were set up in this game is different from any other game that the development team has messed with before, so we had to kind of create our own special code to control certain things. So here we're defining all the solenoids: out hole, knocker, saucer, right sling, left sling, pop bumper. Each one of them has basically a number associated with it, which is it's the address where you pull the hardware to turn it on. So when you turn on these coils, you have to turn it on for a certain amount of time and then turn it off. Everything is manual. There's no automation here. So if you don't program this right, you can blow fuses, melt things, catch things on fire. This is one of the reasons why these manufacturers don't want people fiddling around with the hardware, because it's very, very easy to damage the game when you have such low-level control of the hardware and you've got devices that you're sending electricity to that can literally catch fire. So it takes a little bit of discipline to even want to kind of try to mess with this. So here's some code. I am compiling it and I'm sending it to the system. So now that that's done, let's turn the game on, see what we got. Okay. Now it's in this weird intermediate mode, so I'll have to resend it up there and cause it to boot. So the game will be booting. I can pull up a monitor, and now it's going, you see. Now this is a very primitive proof of concept of being able to control the game right now. There's a small attract mode which shows a score. You see the flickering on the screen. That's just because of the refresh display rate is different from the camera shutter rate, so it looks like it's flickering, but it really isn't. And see, there's very little lights on here. Mostly it's just all GI. We can go over here and we can zoom in on the serial monitor, because I've got this code set up so that it will give me a little bit of feedback. See, it says entering attract mode, done with setup. Now if I hit a switch on the playfield, you'll see it shows me the switch ID number. So I can test and see what switches are, and it tells it to me, and in this case it's in hex and decimal. I did that for my own. Let's blow some behind the scenes code so I can check out which switches this thing is sensing, and then you kind of map all of those things and then you turn it into program code. So let's take a look at what I've managed to do so far. So the first goal in trying to rewrite the rule set of this game is to actually incorporate the existing rule set into it. So this involves playing the game with almost like a notepad and going over and making note of every single switch, what it does, how many points it scores, and how it behaves. and then making a note of that. How many points does this switch trigger? How many points does this switch trigger? So I do that, and then there's logic. Like this is a bank of right drop targets. So this bank right here, when you first get it down, you get 10,000 points, then it's 15,000, then it's 20, 25,000, then it's special. All of that has to be coded in, every single thing. When you drop the targets down, you have to tell the machine, are all the targets down? If they are, kick the thing back up. But how many milliseconds do you hold the coil to make the targets work reliably? Every game is different. So when the designers were doing these games, they were tweaking all these little things. There's so much testing that goes into, because if you were using a new mechanical assembly and you've got a coil on it, maybe it needs 10 milliseconds hold time, maybe it needs 4. You just don't know until you start playing around with it. So it's really a lot of trial and error. So let's see what I've got coded initially for this game. So I'm going to hit the start button. Oops. There we go. There's a good example. I pressed start on the game. The ball was not in the trough. You have to take that into account. Where is the ball? You know, on most games we take for granted all the little logic that's trying to identify where the ball is and if it's in a hole or whatever. So this game basically, right now there will be no sound because I haven't programmed any sound into it. But the score is working. See up there. So let's just kick a ball into play. So you notice the ball went into the saucer. Now it's going to go into the Golden Cliff saucer. And so that seems anemic. I guess it was just the way the pop bumper was set up. So I'm still debugging it, but every little thing scores points. This scores 10 points. That scores 500. And you know, I can look up here on the scoreboard, right? And let's see, I'll hit an outlane. It's supposed to be 1,000, so now it goes to 6,000. But this is brings up another point. On some pinball machines, when you score 1,000 points, it doesn't just add 1,000. Maybe it goes dit, 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 dit. You know, maybe it does 10 100s and puts a sound with each one. If I want this game to be like that, I actually have to code that special routine, write a function that increments the score, and every time I change the score, I got to tell the machine re-display the score stuff. So everything has to be done manually, and the game is in this continuous loop, just constantly looking for different states that are changing, and it's updating it. So this program is constantly running around and around in circles, checking all the switches, sending information to the displays, and changing the lights. Like you'll see up here, I do have some logic programmed already. This Golden Cliffs, every time the ball lands in there, see how it goes up to 6 and it kicks it out. Now maybe, you know, is that too long for the ball sitting in there? See how it maybe waits a little bit longer. That's not something I might want to tweak, but sometimes if the ball's bouncing around the outside, so 10,000, now it should be 12. There we go. So kick this out. So that takes a little bit, but presumably when the ball falls in the hole, I'll play some kind of cool sound effect. Or hey, we have you now. You know, whatever I want to do. So I will tweak that timing based on what sound effect I want to do and things like that. And I just went through and got all the switches, even this thing. So let's talk about this spinner, because this is a good example of, on this spinner, every spin is 100 points, but every spin lights another one of these 4 lights. Now the bottom one is always lit. So 1, 2, 3, 4, 5. So when you get every 5 spins, it adds a bonus onto the game. I have to program that in. So I'll create a variable that keeps track of the status of how many spins have been done. It'll start off maybe at 1, 2, 3, 4, 5, and then when on the 6th spin, it will give me an add bonus. So I have to code in all that individual logic, and then I also have to write a routine that sets these lights on based on the value of that. So when this thing spins around one time, this light will go on, and the second time this one will go on, and after the fifth time, the lights will go back down to reset to the single one. So I'll have to code every single little functionality like that. Now let's take a look at an example of something that I've already done where I've taken a rule set and I've made it a little bit better. So these drop targets, right now I don't have the lights set up, but that would have awarded 10,000 points. So we can look up there and we can see there's the score, 56,000. So I'm going to knock the targets down again, and it should increment it by 15,000 plus 1,500, because it's 500 for every. That's 500, another 500, and when I hit this last 500, it's going to give me 500 plus 15,000. So there we go, bam. Now, I added an extra feature where if you hit these drop targets in a sequence from the bottom, middle to the top, you get double the lit award. So right now it's 20,000. I know that because we've been running through it. But when I get the routine done, I'll have this lit up appropriately. So if we hit them from bottom up, when I hit this one, it's not going to give me 20,000 more. It's going to give me 40,000. So let's go up to the thing and let's see if it is actually working. So we're going to add 4,500 to that score, ideally. Bam. I'm not doing the math in my head right now, but hopefully that's correct. So it seems kind of anticlimactic right now, but imagine a special sound effect for if you hit them in sequence versus not sequence, you know. And I can do all that. I can create different sound effects for different things. I can take a regular bank of drop targets and add an extra special feature to it. So let me show you, let the ball drain, right? Let me show you a particular feature that was never in any of these early Bally's that's incorporated into this game, and that is a ball save. Okay? So there's the extra ball light right there. And then also right here is the same player shoots again light. There's a 15-second ball save that is now integrated into this game. Let me show you how it works. When a single switch is hit, the ball save kicks off. So let's hit any switch on the play field. Okay, let me hit this top switch. Now watch, this light should start blinking. So that light is blinking, as well as this light right here, just like the ball save on a modern game, right? And what'll happen is when it gets down to 1 second, it'll blink faster, and then the ball save will go out. See that? Bam, it's gone. So that is a feature that was never in the original game, and in order to do that, you've got to kind of keep track of when the first switch was hit and how much time has elapsed, and compare it to a value that's going to be your ball save value, and then you have to control the lights based on all that. So everything is involved some kind of a function that's built to be able to do this. Now, it's pretty interesting and fun when you get down into it, but you have to kind of keep track of all kinds of little things going on, and you have to be careful, because if, for example, you fire too many coils at once, you can easily blow a fuse or cause some damage. So you have to take that into account. So let's try to do something interesting here. So I'm going to kick the ball into play. This is ball 3. And there's the ball save is kicked in. I'm going to let the ball drain. Even though it's ball 3, it will give me the ball back again. Now I can let it drain, and the game is over. So let's try to do something different, just to show you that I actually can control this pinball machine with the computer here. So I've put it now on my program here, and I'm going to send it to the machine, and I'll show you what we're going to do. Now in this case, I'm going to push 3 instructions to the solenoid stack to fire these 3 pop bumpers 5 seconds after I start a game. Now I'm staggering them because I would worry that if I fired all 3 of them all simultaneously, that could possibly blow a fuse. Maybe, maybe not. I don't want to risk it. This is something you have to kind of take into account. So let's take a look. Now the way it's supposed to work is once I start the game, 5 seconds after, it's supposed to go bam, bam, bam. It's supposed to fire those off, just as a kind of like a hello there. So let's see if it works. All right, count 1, 2, 3, 4, something 5, and there you go. So that is an example of the degree of where you can control stuff. I can fire things the way I want, and I can turn lights on. So now comes the fun and slightly tedious part of writing all the little control routines. See, this was 3 instructions sent to the stack. I'm going to pull both of those coils in for 4 milliseconds, and it's going to start 5 seconds after, and then every 200 milliseconds after that, it'll fire the others. Now, to turn that into an actual working pinball machine with rules is much more sophisticated, because you have to keep track of all the different states in the game, what's going on. You also have to think like an engineer. You have to think, what happens if somebody tilted the game out last time and the ball was stuck? And you see, there's already a bug. Check it out. Let me show you where there's a bug. If you look up here, that 10K light, the 10,000 light in Golden Cliffs starts off. Now in this game, that does not reset between balls. Other things do. Like if we put some drop targets down, and now see, it resets the targets. And it's kind of neat. I've got it intelligent. I think some games will automatically pulse the drop targets even if they're not up. So I'll wait for the ball save to time out, and then I'll drain the ball. And it only fires these because since those were already up. So I'm kind of making things a little bit more intelligent. I don't know if the Bally by default smartly did it or not, but I thought, I'm not even going to reset the drops if they're already up. Just save that. So let's I'm waiting for it to time out and I'll end the game. But I think that it only awards 2,000 points, but that 10,000 point light is staying on. So I'll have to go into the code and figure out what's causing it. So here, I'll start another game. And you see that? It automatically starts with the 10 and the 2 lit. So I've got there's our 3. I've got some bug in my code where the 10 is automatically lit at start and it shouldn't be. So I'll have to dive in, and this is the process of doing the rule set for this is going to involve lots of going back and forth and check-in and doing all of that. But in the process, I'll slowly build this thing up and make it into a cool game. So my plan with Paragon is to take it and copy the existing rule set, all the scoring. It's really quite balanced, so there's no real reason to mess with it. And I want all of the instructions on the machine to still apply to the new version. My plan is to add extra modes and special features and redo all the sound, make it really, really wicked sound, because this game has like electronic bleeps and bloops, but it's a Dungeons and Dragons themed thing, so we need to hear griffins and warriors and stuff like that. So I'm going to be doing some videos about creating sound effects, how to incorporate them into things, and I'm also going to show you some interesting tricks and techniques that I'm kind of looking to do, because I've always wanted to customize my own pinball machine. So I've been thinking for years of interesting ideas. I don't know if somebody has thought of all of these things, but for example, can I time music to coils in an interesting way? Like obviously, if pop bumper gets hit, you can hear doosh, doosh, or something like that, right? But could you have background music that gets synced to coils too? I don't know. That's something, I'm sure maybe somebody has done it. But you could use a coil firing as a kind of a percussive accent to some background music if you wanted to. There's lots of interesting things. Like I said in the previous video, this is just a 3-bank set of drop targets. But what if you got an extra reward if you hit them in a particular sequence? Well, I'm coding that into things. These games also didn't have skill shots, so I'm going to put a skill shot in here. Now, what kind of skill shot should there be? How do you do a skill shot with this? I think it's going to have to be alternate between, say, a 2000, 10, 20, or special or something like that. You know, and it'll just blink, 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 and if you get it in the corresponding hole when it's lit, it becomes something special. And I could do something like that, and then every successive time it goes a little bit faster and it's harder to time. That might not be a bad skill shot. We'll have to see. So that's an idea. I could have these things cycle really fast, and when you hit the advanced bonus, it freezes on a particular value. That would be kind of cool. I could do the same thing with Paragon. I could have it fan the Paragon so that it starts with one lit, then 2, 3, 4, and it's faster. And if it falls in, then you could light multiple letters. I mean, that's an idea. I don't want to unbalance the actual gameplay, though. So I'm going to play around with it. If you've got ideas, though, leave them in the comments. Let me know what you think. How would you alter this rule set and make it a little bit more interesting? I am open to ideas. This is a collaborative project. So that's it. But stay tuned for more, and thank you guys for watching, and be sure to subscribe on YouTube and visit my website, PinballHelp.com.